We say that the angle in its standard position, if the initial side of the angle is the positive direction of x-axis and the vertex of the angle lies on the origin point. Once again, we say the angle in its standard position if the initial side of the angle, is the positive direction of x-axis and the vertex of the angle is the origin point. So here, this angle in its standard position, this angle is theta, and this angle lies in the first quadrant from 0 to 90. And here, this angle in its standard position, because this side is the initial side and the vertex is the origin point, and this angle lies in the second quadrant. Here, this angle in its standard position, here, the positive direction of x-axis is the initial side, and the terminal side, this side is called the terminal side. Here, this side is the terminal side, and this side is the initial side. This angle lies in the third quadrant, and this angle here lies in the fourth quadrant. The initial side is the positive direction of x-axis and the vertex is the origin point. Here we are going to talk about related angles. What is the meaning of related angles? We say that the two angles are related to each other. They are not exactly the same, but they are close enough. So we say that the two angles are related angles. Firstly, what is the size of this angle in its standard position? This angle here is theta. And if this is the unit circle, so its radius length, the radius length of the circle is 1. X here represents what? Cosine, as you know, and y represents sine. What about this angle? Don't say theta. This angle in its standard position is 180 minus theta, because we take positive direction of x-axis as initial side, and here that's the terminal side. This angle here is theta, so we can say that this angle is 180, this is 180 minus theta, so this angle is 180 minus theta. Okay, you observe that x will still the same x, but there is something change in the sign here. The change only is in the sign, but the value here of x is the same value here of x, and the value of y will still the same, will remain y. So let's assume that this point here is 0.8 and 0.6. You know, 0.8 to the power of 2 plus 0.6 to the power of 2 is equal to 1. Here, this point will be what? Negative 0.8 and 0.6. So, if I ask you about cosine theta, you will say 0.8. If I asked about sine theta is what? 0.6. What about sine and cosine 180 minus theta? What is the cosine 180 minus theta? Cosine 180 minus theta is negative 0.8, and the sine 180 minus theta is 0.6. So we can generalize this rule. Sine 180 minus theta is equal to what? Is equal to sine theta. The same, y is the same here as y. And cosine 180 minus theta is equal to what? Is equal to negative cosine theta. Here, cosine is negative is 0.8 here, and here cosine is negative 0.8. They are the same. They have the same value, but the difference between them in the sign only. So cosine 180 minus theta is negative cosine theta, and tan 180 minus theta You know tan theta is equal to what? Equal 0.6 divided by 0.83 over 4. And tan here will still the same. 0.6 divided by negative 0.8, it will be negative 3 over 4. So tan theta is the same as tan 180 minus theta, but has a different sign. So tan 180 minus theta is negative tan theta. So if I asked you about sine 150, how can we express 150 as 180 minus a special angle? So 150 can be written as what? As sine 180 minus 30. Sine 150 is the same as sine 180 minus 30. So here we have 180. So the angle sine 180 minus 30 is going to be equal to sine 30, which is half. As I said before, that sine 180 minus theta is equal to what? Sine theta. Once again, sine 180 minus theta is equal to what? Sine theta. What if I asked about cosine 120? You know 120, by the way, lies in the second quadrant, and cosine in the second quadrant is negative, so don't panic yourself in the sign. Cosine 180, 120 lies in the second quadrant, and cosine in the second quadrant is negative. But now, the question is, how can we express 120? We can express 120 as 180 minus 60. And as I said, cosine in the second quadrant is negative, so we're going to write negative cosine 60. That is equal to negative. Cosine 60 is equal to half. That's it. Let's go to this angle here. Look at this angle and this angle. This angle in its standard position is theta, because the initial side here is the positive direction of x-axis. What about this angle here? You know that the initial side is the positive direction of x-axis, and this side is the terminal side. So this angle is going to be what? 180 plus theta. You will find that this point, the two coordinates of this point, x and y, and the two coordinates of this point are going to be negative x and negative y. They have the same value, but the difference in the sign. Okay, here x has a different sign, and here y here has a different sign than this y. So here let's take an example. Let's take 0.8 as x and 0.6 as y, like the previous example. So if I asked you about cosine theta is 0.8, and sine theta is y is 0.6. What about sine 180 plus theta? As I said, they are two related angles. They are close enough to each other. So x will still the same, but the difference will be in the sign. So it's negative 0.8, and here y is negative 0.6. Okay, so sine 180 plus theta is the same value of sine theta, but the difference in the sign. So it will be, and 180 minus theta, by the way, lies in the third quadrant, and the sign is negative. Okay, so sine 180 minus theta is equal to negative sine theta. And what about cosine? Cosine 180 plus theta. Cosine 180 plus theta, here cosine is 0.8, and here cosine is negative 0.8. So it will be the same, but the same value here, but different sign, negative cosine theta. So cosine 180 plus theta is equal to what? Negative cosine theta. What about tan? Tan here is positive, because negative divided by negative is positive. So tan 180 plus theta is equal to what? Is equal to tan theta. Let's take an example. What if I asked you about tan 225? So, first of all, 225 lies in the third quadrant. So write third quadrant. And the sign of tan in the third quadrant is positive. So write positive. And now, how can we express 225 as 180 plus an angle? So we can write it as tan 180 plus 45. Okay? So this angle is going to be equal to what? As I said, tan 180 plus theta. Tan 180 plus theta is equal to what? Is equal to tan theta. So that is going to be equal to what? Tan 45. And tan 45, as you know, it's 1 opposite over adjacent, so it's 1. That's it. What about this angle here? We have two angles. This angle here is theta in its standard position, and this angle is what? Is 360 minus theta in its standard position. So we take this side as initial side. This is the initial side here, and the terminal side, this side. This angle is 360 minus this angle theta. We observe that here x and y, and here is x and negative y. Cosine here is the same as cosine here, and sine here is the same as sine here, but the difference between them in the sign. Okay, so here it's y and here it's negative y. So let's take an example. Let's write 0.8 and 0.6. Any two coordinates. Here this point is going to be 0.8 and negative 0.6. What I want to say that cosine 360 minus theta will be the same as cosine theta. Cosine 360 minus theta is going to be the same as cosine theta. What about sine? Sine 360 minus theta. You know, 360 minus theta lies in the fourth quadrant and sine is negative. So that is equal to negative sine theta. That is equal to what? Negative sine theta. Here it's y and here it's negative y. What about tan? So tan 360 minus theta is going to be equal negative tan theta. Let's take an example. If I asked you about, let's say, sine 330. So first of all, this angle here, sine 330, this angle 330 lies in what? Lies in the fourth quadrant. And the sign of sine in the fourth quadrant is negative. Okay? Now how can we express 330 as 360 minus a special angle? So we can write it as sine 360 minus 30. That is equal to, that will be equal to negative. Negative what? Negative sine this angle here 30. So it's negative sine 30 is equal to negative half. That's it. Now let's focus on these two angles. Actually, they are related angles, but not related enough like the previous angles. Because here x and y, both of them, x has been changed to negative y and y has been changed to x. Let's check it well. So here we have an angle. This angle is theta. And this angle here is theta. Let's analyze it. Here, if I assumed that I have angle here, let's say 20 for instance, and this angle here is right. Okay, they with me? They are two perpendicular lines. So this angle is going to be what? 70. Because x and y are two perpendicular lines, x-axis and y-axis. And this angle is going to be what? 20. So what I want to say that this angle theta and this angle is theta. They are the same here. This angle here is theta. So this is 20 and this is 20. Like this example here, this angle here, it's a theta, and this angle here is theta. To make it easy, let's take an easy example and be focused, please. Let's take this as 0.8 and 0.6. What I mean by that? The length here on x-axis, here the length on x here is 0.8. The length here is 0.8. This is 0.8. And the length on y is 0.6. The length here is 0.6. Here you will find this length here, because the two triangles are two congruent triangles. You will find that this length here, I mean that this length here, I said that this is the length here is 0.6 and the length here is going to be what? 0.6 but negative. So here it's negative 0.6. This is on x. This is x-axis. This is negative 0.6. Okay? And here this is 0.8. So the length here is going to be 0.8. Here it's 0.8. If we focused again on this triangle, you will find the two coordinates of this point are going to be negative 0.6, negative 0.6, and y is 0.8. So x and y, both of them, x has been changed to y. Don't care about the sign now. Leave the sign now. And y it changed into x. But because we are talking about an angle in the second quadrant, so the cosine is negative. So the first coordinate is negative. What I want to say, sine 90 plus theta. Why I said 90 plus theta? Because this angle in its standard position is what? Is 90 plus theta. This angle is theta. Sine 90 plus theta is equal to what? Sine 90 plus theta. 90, as you know, 90 changes from sine to cosine. 90 plus theta lies in which quadrant? Lies in the second quadrant. 90 plus theta. Okay? And the sign of sine in the second quadrant, the sign of sine is positive. So write positive. But 90, it changes from sine to what? To cosine. Okay? So sine 90 plus theta is equal to what? Cosine theta. Sine 90 plus theta here, that's the sine here. 0.8. Like what? Like cosine here. The same. They are the same. So sine 90 plus theta is equal to cosine theta. What about cosine 90 plus theta? Cosine 90 plus theta. Ask yourself about the quadrant. 90 plus theta lies in which quadrant? Second quadrant. Okay? What is the sign of cosine in the second quadrant? The sign of cosine is negative. Cosine is negative. Okay? So cosine 90 plus theta equals negative. Equals negative. And the 90 changes from cosine to what? To sine. So that is going to be sine negative sine theta. So here, cosine 90 plus theta, it's what? 0.6. This cosine 90 plus theta is equal to what? Is equal to negative sine theta. This is sine theta 0.6. Okay? What about tan? Tan 90 plus theta. We are talking about an angle lies in the second quadrant. So write second quadrant. What is the sign of tan in the second quadrant? The sign of tan is negative. Here it's a positive divided by negative. Sine divided by cosine. So tan 90 plus theta is equal to what? Negative But because sine and cosine, both of them has been changed, so that will be equal to negative cotan theta. So tan 90 plus theta is equal to what? Negative cotan theta. Let's go to this unit cycle here. As I said, this is 1 and this is 1. As you see here, x and y, the two coordinates are x and y. This angle here is what? This angle is theta. And this angle is 270 minus theta. This angle is 270 minus theta. So we are talking about angle theta. The first angle is theta. And the second angle is what? 270 minus theta. This is the initial side. And this is 270 minus this angle minus theta. Okay? As you see here, x and y, x has been changed into y, and y changed into x. Don't care about the sign now. But what I want to say is sine is going to be cosine and cosine will be sine. So 270 plus theta and 270 minus theta, 90 plus theta and 90 minus theta. All these angles, it changes from sine into cosine and from cosine into sine. So here, sine 270 minus theta. Don't panic yourself every time in drawing a unit cycle. Just ask yourself this question. 270 minus theta lies in which quadrant? In the third quadrant. Lies in the third quadrant. And in the third quadrant, sine is positive or negative? It's negative. So write negative. But as I said before, 270, it changes from sine into cosine. So that is going to be equal to cosine theta. Negative cosine theta. Okay. What about cosine 270 minus theta? 270 minus theta. Ask yourself these questions. What about the quadrant? Third quadrant. This angle here in the third quadrant. Okay. What is the sign of cosine in the third quadrant? Is negative. So it's negative. But remember that 270 changes cosine into sine. So that is equal to what? Negative sine theta. What about tan? Tan 270 minus theta. The same. 270 minus theta lies in which quadrant? In the third quadrant. What is the sign of tan? It's positive. And 270 changes from tan to cotan. So that is equal to what? Cotan theta. Okay. This is this angle here. This angle is theta, as you see, in the first quadrant. And this angle is 270 till here. This is the initial side. So from the initial side to the terminal side here, this is the terminal side. Okay. This is 270 plus this angle plus theta. As you see here, x and y, both of them, x has been changed and y changed into x. So sine will be cosine and cosine will be sine. So if I ask you about sine 270 plus theta, ask about the quadrant. What is the quadrant here? The quadrant here, this angle lies in the fourth quadrant. Lies in the fourth quadrant. What is the sign of sine in the fourth quadrant? It's negative. But 270 changes from sine into cosine. So that is equal to negative cosine theta. What about cosine 270 plus theta? The same questions. Ask yourself about the quadrant. It's the fourth quadrant. This angle lies in the fourth quadrant. What is the sign of cosine? It's positive. So it's a positive. But 270, it changes from cosine into sine, so it will be sine theta. What about tan? Tan 270 plus theta. Ask about the quadrant. Which quadrant? 270 plus theta lies in the fourth quadrant. Okay, and in the fourth quadrant 10 is negative, so write negative. 270 changes from tan into cotangent theta. Okay, so let's generalize what we have studied in related angles. 90 plus theta, 90 minus theta, 270 plus theta, 270 minus theta. Changes from sine to cosine and from cosine to sine, and changes from tan to cotangent and from cotangent to tan, and it changes from sec into cosec and from cosec into sec. The angles theta 360 minus theta, 180 minus theta, 180 plus theta. Sine will still sine, will remain sine, cosine will remain cosine, and tan will remain cotangent. But ask about the quadrant, ask about the quadrant, then ask about the sine. So if I asked about sine, 210. 210 lies in which quadrant? Lies in the third quadrant. What is the sign of sine in the third quadrant? It's negative. So third quadrant and sine is negative. Now how can we express 210? We can express 210 as sine 180 plus 30. Okay, so it will be negative sine 30, which is equal to negative half. Here, if I asked about tan, 330. 330 in which quadrant? In the fourth quadrant. What is the sign of tan? Tan in the fourth quadrant is negative. How can we express 330? We can express 330 as 360 minus 30. So that is equal to tan 360 minus 30. Write negative tan 30. What is the negative tan 30? It's a negative, you know, this is the 36th triangle. 30, don't use the calculator, it's here 1 and here 2 and here it's root 3. So tan 30 is opposite over adjacent, so it's negative 1 over root 3. That's it. Now let's go to the net circle again. Don't use the calculator in these angles. This angle here is 1 and 0, that's cosine and that's sine. And here the two coordinates negative 1 and 0, cosine and sine. And here 0 and 1, cosine and sine. And here 0 and negative 1, also cosine and sine. You know that this side is the initial side. If I asked about cosine 0, it's 1. Sine 0, 0. What if I asked about cosine 90? Here it's 90. Cosine 90 is 0 and sine 90 is 1. What about 180? The same. Cosine 180 negative 1 and sine 180 is 0. What about 270? If I asked about cosine 270, it's 0 and sine 270 is negative 1. What if I asked about tan 90? So tan 90 equals sine 90 divided by cosine 90 is equal to what? 1 over 0, it's undefined. Okay. What about cotan 90? Cotan 90 is cosine over sine for the angle 90. So it's 0 over 1, which is equal to what? 0. Now let's take this triangle, 36 degree. This is 30 and this is 90, this is 60. Here it's 1, 2 and here it's root 3. By using this triangle we can find sine, cosine and tan. And if we have a triangle 45 and 45, this triangle is an isosceles triangle. This side is 1 as you know and this side is 1. This is a square root of 2. By using these two triangles we can find sine, cosine and tan for any of these two angles. So don't use the calculator. Depend on the unit circle and depend on the two triangles.